Hello students, here Imalisha. Today we are going to study about the issues related inter-process communication. So there are mainly three issues which is arised during inter-process communications. These are given as follows. First, how one process can pass the information to another. So, to communicate means to share some information or to pass information to others. Right? So, one process can pass information to another by using shared memory and shared files. Like message passing, we have already seen how to interact the communication. Right? Sockets, share files, share memory. There are so many ways. Next, two or more process should not get into each other's way. So suppose one process is printing some document in printer. Meanwhile, some other process comes which also wants to print the something. But it should wait till the first process finished its printing. So thus, second process should not come in way of first one. So this is the second issues related to the APC. Next, a proper sequencing should be maintained in execution of process when dependencies are present. See, consider the two processes. Process A produce some data and process B prints some data. Here the B has to wait for process A. It cannot be start to print until the A process produce some data. Thus, proper sequencing should be maintained. Say in this example, we can consider the process A is producing some data and process B is printing some data. Right? So, printing is not possible up to the until they produce the data. Right? So, this is how to communicate. This is called as issues related to IPC. Next, process synchronization. See, a cooperative process we have already seen that is affected the execution of another process or can be affected by the execution of other process. Such processes needs to synchronize so that their order of execution can be guaranteed. See, cooperative process that we have already seen, one process is affected, can be affected the execution of another process. So that might be conflict in the particular execution of process, right? That's why we have to synchronize the process. That's how the possible. Next, the procedure involves the preserving the appropriate order of execution of cooperative process is known as a process synchronization. Right? So uh, in simple word we can say the process synchronization is a mechanism to ensure a systematic sharing of resource among the concurrent process. This is about the process synchronization. Let's see some problems which arise in the interprocess communication, and the solutions are this we have already seen, right? But this is the how race condition arise. See, P1 and P2 processes are there, right? P1 and P2 processes are there, and we have to given some code of segment, right? For example, P1 started the execution, then see here the B is a shared variable. Okay, so it will consider here also and it will consider here also. So we have defined the value of B, that is 2. Let's see what happened. The first integer A equal to B. That means the value of B is allocated to A. So here we can say integer A equal to 2. Next A plus plus. So it will become 3. Right? So here the value of A, that will be 3. Right? Next, sleep 1. That means what? We have already seen the scheduling. In scheduling algorithm, we have already seen the one process has to wait until the second process is finished, as in the FCFS. But whenever it goes into sleep mode, that means it will be skipped. Another process can execute its operations. So this is about the sleep. So whenever it goes to the sleep, then next process continue its work. So this is the next process execute its work. P2 started the execution. Now what happened? The integer C equal to B. Then the value of C became 2. And C plus plus, that means it will same as 3. But in place of that, we have considered the C minus minus. Let's see, we have considered the C minus minus. Then what happened? The value of C became 1. Okay. So, next sleep. So, it will be resume P1 process. Now next B equal to A. See here we have seen B equal to A. B equal to A, that means the value of, see here, value of B, that is the 3. Right? And next C equal to A. That becomes, if I consider the C minus minus, then it will become a 1. So it may be fluctuate here. This we can see the value of B and C. The value of share variable, it may be change. It may be 3 or it may be 1. So how it's possible? So this is called as race condition. See, from among two values, which values we have to consider for further operations, that might be confused. It's like a racing. We have to consider 1 or 3, right? It might be not possible. So in this situation, when 2 or more processes are reading and writing some shared data, and the final result depend on the relatively order. See, we have already seen this example. So order of the execution is called the race condition, or we can say racing problem. So this is about the racing condition. Next, critical section. So critical section, that is nothing but the critical region, we can say. Critical region, that is the code of segment which is shared, right? Let's see. When more than one process are accessed to the same code of segment, that segment is known as a critical section. That means it contains shared variables or resources which are needed to synchronize to maintain the consistency of variable. Right. So here the structure of critical section we have to give the first, that is the entry section. Entry section, that means, see, let's simple example at our entrance of home. Entrance of home, we have to fulfill some requirements, then and then we can enter in our home. If suppose we are going to some friend's home, right? Then we have to write down all the details of ours within their phone number and all. So this is the entry section, that is a fulfill some requirement of the process, right? So in this section, entry section, that segment is executed when the process want to enter, it's a critical section. Eligibility of the process to enter the critical section is checked here. If all the requirements are satisfied, then process is allowed to enter in the critical section, as it will have to wait all the requirements are not fulfilled. This section is ensure that most one process in the critical section, only one process in the critical section. See, in the critical section, that is a code of segment wherein the process access a shared resources. In this section, at a time, only one of cooperative process will be its a critical section. So when the process is executing its a critical section, it is enjoying an exclusive access to the shared resources. Let's see about the exit section. This code of segment is executed when the process exit its critical section. So exit of our home, we can say simple words. A process performs the certain operations and indicating its exit from the critical section. That is the critical section. So this exit section is also enabled one of the waiting process to enter its critical section. Okay. Now the reminder section. Reminder section, that means what? This is the remaining part of the process code. In this section, the process perform the task which are independent from the other process. Means they doesn't include use of any shared resources. So this is next, while true, means this condition becomes true, then and then we have to execute this code. This is called as a critical section. Let's see the solution of critical section problems. First, that is a mutual exclusion. When the process is executing its critical section, then no other processes can be executing in their critical section. Let's see, here we have to given the two process P1 and P2. Now, in the critical section, we have given that is a shared code CS, that means critical section. If P1 wants to execute its code, right, and that we have to consider first that is empty critical section that is empty, then P1 is allowed to go there. Means P1 can access the shared variables or shared resources. When P1 is in critical section, then P2, if P2 wants to go there, then it is not allowed. Why? Because mutual exclusion, that means only one process can execute or can use the shared variables at the same time. Same to same, for example, P2 P2 is in the critical situation, critical section, and at that time the P1 wants to execute its code, then it is not allowed. So in short, we can say mutual exclusion means at the same time only one process can execute its code in the critical section. Okay, next, that is the progress. Progress means what? If no process is executing its critical section. So we have to first consider that P1 and P2 processes are there and critical section is there. We have to consider first that there is no process in a critical section. There exist some processes that wish to enter P1 and P2. Then selection of this process that will enter in the critical section next cannot be postponed the identifiably. Let's see, the P1 wants to enter in the critical section, right? But somehow P2 is postponed to, or we can say it's not allowed to execute the P1 process. The question arises, why it happens? Why? Then the entry section code of P2 is like quite typical. That is blocked to P1 process. See, that is the continuous blocking the first process, then it is called as a starvation. So we don't have to happen the starvation at a time. Then we have to consider that the P2 is not postponing the P1 process. In the simple words, we can say if among two processes, any process wants to execute its code whenever the critical section is empty or there is no process in the critical section, then available two processes, the selection of two processes that is enter into the critical section, the next process is not postponed identically. This is called as a progress. Next, see, we have seen the mutual exclusion and the progress. These are the primary solution, and this is the secondary solutions of the critical section problem. A bound must be exist on the number of times that another process are allowed to enter the critical section. Let's see, we have already given the example. P1 and P2 process are there, and in the critical section, if suppose P1 is entered into the critical section, right? Critical section, so P2 has to wait until the P1 is unblock this code. right? Then if suppose P1 has finished the execution, next again in place of P2, P1 has started to execute, then it's also fine. But next time also it's finished the completion its work, and again P1 has started to execute, means it is entered in the critical section. The next time this is quite happen again. If it is happen again and again, then might be it will be goes down in the infinite loop. And if it suppose goes into the infinite loop, then it will be not execute the P2 process. That is same as the starvation. P2 is blocked, right? So we don't have to make this situation. That's why we have to bound it. If suppose the 4 times it's execute the P1, but at least once P2 is execute, right? At least one the P2 execute, then that this situation is called as the bounded waiting. We have to assume that each process execute at a non-zero speed, and no assumption concern relative the speed of the end processes, right? So a bound must be exist the number of times that other process are allowed to enter that critical section. After process has to make the request and enter its critical section, and before that the request is granted. So this is about this solution of critical section problem. Hope you understand. Thank you.